This tutorial is about pipe sizing for industrial and commercial heating and cooling piping systems using glycol mixture. This is Mosabet. The glycol mixture is used in hydronic systems to prevent freezing, especially for systems operating at below freezing temperature. The mixture is either propylene glycol or ethylene glycol mixed with water at a certain concentration. For example, for a cooling system operating at -20 degrees Fahrenheit, that is below freezing, a 50% mixture by volume is needed. I have a tutorial for determining the glycol freezing point on YouTube. Sizing the glycol piping is super easy. We can use the online engineering calculators called propycalculators.com. I prepared this website, and it is available for free. Let's go to Google and search for propycalculators.com. I will leave the link in the description. There are many useful engineering calculators on this website. To determine the size of glycol piping, we need the pipe sizing for glycol calculator. Clicking on it, the page opens. The calculator is good and accurate for carbon steel piping and can be used in two different units, IP or inch-pound units and SI or metric units. Note that the calculator does not adjust the input numbers when the unit changes from one to the other. Separate inputs are needed for each unit group. For this tutorial, I select the IP units. To calculate the pipe size, 5 inputs are needed. The glycol type, either PG for propylene glycol or EG for ethylene glycol. The mixture concentration. The average operating temperature. The required glycol flow rate. And either the allowed pressure drop in psi per 100 feet of pipe or the velocity in feet per second. As an example, let's select the PG for propylene glycol. Mixture concentration of 35%. Average temperature of 48 degrees Fahrenheit, assuming 42 degrees Fahrenheit glycol supply and 54 degrees Fahrenheit glycol return. Glycol flow rate of 900 GPM. And glycol pressure drop of 1 psi per 100 feet of pipe. The calculated data are 8-inch pipe, velocity of 5.77 feet per second and actual pressure drop of 0.75 psi per 100 feet of pipe. If I change the concentration from 35% to 70%, the pressure drop will increase to 1.08 psi per 100 feet of pipe. The pressure drop for these conditions will exceed our input or allowed pressure drop of 1 psi per 100 feet of pipe. If this calculated pressure drop, that is based on an 8-inch pipe, is not acceptable, then the pipe size must be increased to the next size, in this case to a 10-inch pipe. Testing the 10-inch pipe, the new calculated data are pressure drop of 0.37 psi per 100 feet of pipe and velocity of 3.66 feet per second. This calculator is very flexible and can be used to analyze the outcome of different situations by using different inputs in its drop-downs menu. There are recommendations here for sizing glycol mixture piping that can be used for projects with no engineering standards to follow. Let me know if you have questions and comments for the online calculators or if I can help you with this type of engineering design and calculations. I will get back to you. Thank you for watching.